Hello everyone, welcome to my YouTube channel. In this video, I will demonstrate a very interesting phenomena, that is the diffraction of light. To perform this activity, I will be using a laser light. Laser, it stands for light amplification by stimulated emission of radiation. It is actually a source of highly intense, monochromatic, coherent, perfectly parallel beam of light. I have also used two razor blades, a wooden plank, thermocol and a screen. The surrounding area and the screen have been darkened using black chart paper to make the diffraction pattern clearly visible. So here I have made use of black chart paper, and these are the razor blades which I will fix on the thermocol. These two razor blades are fixed vertically on the thermocol sheet in such a way that they are very close to each other, forming a narrow slit. Now students, the width of this slit is made comparable to the wavelength of the laser light. This condition is mandatory for diffraction to occur. I again repeat, for diffraction of light to take place, the width of the slit should be comparable to the wavelength of the light. That is when the phenomenon of diffraction will be observed. Now, first let's observe what happens when the laser beam is directly incident on the screen. We can see a bright single spot corresponding to the laser light. This is a single spot which we obtain on the screen, right? No diffraction is taking place whatsoever. Now, when the laser light is passed through the narrow slit, something interesting happens. The light bends around the edges of the slit and spreads out into the region where geometrically it should not have reached. This bending of light is what we call as diffraction. On a screen you can see a diffraction pattern, a bright central maximum which is flanked on both sides by alternating dark and bright bands which are known as secondary minima and maxima respectively. This pattern confirms that light behaves as a wave because only waves can bend and interfere in this manner. Thus, this simple setup beautifully demonstrates the diffraction of light through a single slit. The pattern consists of a central maximum which is flanked on both the sides by secondary minima and maxima, which progressively fade in intensity as they move away from the center. Thank you students, thank you for watching this experiment, and if you found this experiment interesting, don't forget to like, share and subscribe to my channel for more educational physical demonstrations. Thank you.